Hey there, it's Jeff, creator of Fingers Touches for Unity. This tutorial video will go over everything this asset can do for you. It's very easy to set up and get brought into your Unity game, so I'll show you how to do that now. What I would suggest you do is create an empty game object and name it FingerScript, like I've done here. I've attached my demo script to this object, and I've also attached the FingerScript, which is the main resource in this asset. If you look in the Fingers folder, you'll see a demo and a script folder. You'll want to go to the script folder and drag the FingerScript into your game object, which I've already done, so I don't need to do that again. You'll notice all of these gestures in here. Those are all accessible from scripting, so you can create these gestures and get callbacks for each of these kinds of gestures in your scripts to do appropriate behavior in your game. Let's go over the parameters real fast. There's not too many, so it's nice and easy. On the FingerScript, you have treat mouse pointer as finger. This allows you to use the left, middle, and right mouse button as individual fingers. You can also use the shift key and the control key to rotate and pinch and zoom. So let's give you a quick demo of that right now. I'm running on Windows here, not a touch screen at all. I'm just moving my mouse cursor here. But as I press shift, you can see that it's putting two fingers down. I've got a two-finger pan gesture that lets me kind of drag the earth around, but if I use the mouse wheel, it'll start rotating those fingers, and you can simulate a rotate gesture. And then the control key, same thing, brings them in to zoom out and brings them further apart to zoom in, just as you would on any touch screen. So very, very handy to not have to deploy to your Android or iOS device or Windows tablet in order to test simple things like pinching, zooming, and rotating. Okay, default DPI is a way to tell the script what to do if Unity can't figure out what the DPI is. Since this asset works in inches, it needs to know the DPI to calculate various thresholds, such as, hey, when should a pan gesture start? It doesn't start when the finger goes down. The finger has to move just a tiny bit, and the script uses the DPI to determine how many inches or fraction of an inch that the finger has moved in order to determine if that gesture started. So you can set that to a value different than 200. I think 200 is probably fine, but feel free to change that if you don't like it. Okay, let's get to the public methods of FingerScript. There's only a couple. Most of the time here will be spent in the demo script to show you how I'm interfacing with all these gestures and stuff. So let's go over to Visual Studio, look at the FingerScript, go to the bottom. You can see there's a couple of public methods. This is literally all there is as a public interface to this script, and it allows you to add gestures to the script so that they start receiving callbacks. You can take gestures out if you don't want them to get callbacks anymore, and you can get a collection of all touches on the screen. That's pretty much it. All the other stuff is simply a Unity driver to take all the Unity touches and the mouse and get touch events and send them to all of the current gestures. Alright, let's go back to Unity. You'll see that I've added a demo script here right above FingerScript. It has a reference to FingerScript so that it can add and remove gestures. I've got the earth here in the background. The DPI label will get populated when the game runs. I've got this asteroid prefab that I use for tap gestures. Whenever you tap, it will create an asteroid. And I've got a line material so that when you swipe it, I can draw a line to show you where you just swiped. Finally, I've got these 10 touch circles. So up to 10 touch events will be tracked with a circle, as you saw earlier when I did the pinch and zoom and rotate gestures. Okay, let's go down to the demo script and show you how all of this works. For your own game, here's what I would suggest. I would suggest getting a start method of your own script and setting up all of your gestures there, like I've done. I've created all of these gestures. I have a tap gesture to create asteroids. I have a double tap gesture which will remove asteroids. A swipe gesture which will push asteroids out of the way. I have a pan gesture which allows me to drag the earth around. A scale gesture to make the earth bigger or smaller. A rotate gesture to rotate the earth. And I have a long press gesture that will allow me to grab hold of an asteroid and fling it. Okay, so if you've used iOS before, UI Gesture Recognizer is kind of the inspiration I got for this script. You can have other gestures require other gestures to fail. So in this case, I have a single tap gesture, which creates an asteroid, but in order for that gesture to fire, I need the double tap to fail. So I set on the tap gesture, I say, hey, since you have a tap and a double tap, I need that double tap to fail. Otherwise, you could get a double tap gesture firing along with two taps, which would not be what you want. So if you're using taps and double taps, you'll need to make sure to set require gesture recognizer to fail on your single tap gesture. Finally, as you saw, I was able to pan, scale, and rotate the Earth all at the same time. Gestures in this script are exclusive by default, so if one gesture starts executing, no other gestures will be allowed to execute until that gesture finishes. However, you can override that by allowing simultaneous execution with other gestures. Now this works both ways. This pan gesture allows simultaneous execution with scale gesture, means that scale gesture can work simultaneously with the pan gesture. You don't need to set it both ways. It automatically links it both ways for you. In addition, the pan gesture works simultaneous with the rotate gesture, and the scale gesture works simultaneous with the rotate gesture. So those three separate gestures, all of them can act simultaneously with each other. So here's the kind of what I suggest for your setup. Create all of your gestures in your script in the start method. Let's look at how these are created now. Tap gesture is pretty easy. You create new tap gesture, you set the updated callback, which is similar to UI Gesture Recognizer's callback, and you set it to a method. Now I had some trouble on iOS using inline lambda expressions, so I've set my callbacks to be actual methods just in case. Now this was like a few months ago, maybe Unity's fixed that by now, but to be safe you probably want to have your methods in the script rather than inline. And then finally, once this tap gesture is created, I simply add it to the finger script, and now that gesture is ready to get callbacks. Let's take a look at this updated method so you can see how this works. Tap gesture callback. Each callback has the same signature. You'll get the gesture recognizer with the callback, and you will get the collection of current touches for that gesture. For a tap gesture, there's really only one state you care about, and that probably is when did the tap finish. And then you can do some logic there. Here I just pull out the first touch. I say, is it valid? And then I create an asteroid where they tapped. Is valid is just a way to make sure you have a valid pointer. If there's something going on in Unity or iOS or Android where touches are being funny, you can call is valid and it will make sure that you've got a valid touch rather than some garbage touch. So it's probably good to call is valid if you're seeing some funny behavior. You might be able to get away without calling it, but I would suggest calling it just to be sure. Okay, so there's the tap gesture. Creates an asteroid at the XY point. Great, so let's move on to the double tap gesture. Same thing as the tap gesture. When that double tap ends, if it's valid, I remove asteroids within 16 world coordinates. So it's basically a way to wipe out asteroids. A lot of games you may want to zoom if someone double taps, but in my case, when they double tap, I'm just removing asteroids near where they tapped. Okay, let's look at how that double tap gesture is created. It's exactly the same as the tap gesture, except you can say number of taps required to be a higher number. In this case, 2 for double tap. Okay, let's move on to the swipe gesture. A swipe gesture is just a way to swipe rapidly. This script is good because it doesn't count swipes if your finger is moving slowly. So your finger has to move rapidly, and it can determine the direction even. So let's look at the setup for a swipe gesture. You've got the direction. In my case, I don't care which direction it moves. It can go up, down, left, right, diagonal, whatever. But if you only want to swipe right, you can set this to right or left, up or down. And then only if this finger swipes in that direction will you get the callback for this gesture. Same thing as the tap. gestures, I set the updated method and I add the gesture. There's also a direction threshold. This is kind of not necessary when your direction is any, but if you set your direction to up, this would be kind of the variance. How far to the left and right could they move versus how far it's going up. It's just a way to say, hey, how diagonally can they move their finger before it's no longer moving up. I think the default was 2.5. In this case, this line's not really needed, but I just left it in there to give you an example of that parameter. So when the swipe gesture finishes, here's what I do. I look and see, hey, where did they swipe? Wherever they swiped, I create a kind of a wave, a shock wave, if you will. If you look at it here, I've got the start point, which on the swipe gesture you have start X and start Y, so you can know where the finger started. And then I have the end X and end Y, and basically what I'm doing is ray casting out kind of a shock wave that pushes asteroids out of the way. Let me just show that to you so it makes more sense. Alright, so let's create some asteroids here. I'm going to swipe fast. See if your finger doesn't move fast enough, it doesn't count as a swipe. And that's configurable on the gesture. You can configure velocity needed. In my case, I just left the defaults, but as you can see, if you move slowly, no swipey, fast, gets a swipe and shoves them out of the way. Okay. Let's move on. Let's see, we did swipe gesture. Now let's look at the pan gesture. A pan gesture is simply when you're dragging your finger around. You may have seen this on iOS with a scroll view and Android scroll view as well, where you can kind of move content around with your finger. Pan gesture is really nice for that. In my case, my pan gesture requires 2 touches. So you can see when I create the pan gesture, I require 2 touches. And this is so that it doesn't interfere with my swipe gesture. If I move 2 fingers really fast, the pan gesture is going to fire and the swipe gesture won't execute. If I move 1 finger really fast, then the swipe gesture executes. If I did not have this line here, then the pan gesture and swipe gesture would be fighting with each other, and that would not be ideal. Okay, so when I pan, I move the Earth around. So if we look at the callback that's assigned here, we can say, hey, if the pan is still executing and valid, let's check out what's going on. In this case, I look at the delta X and delta Y. I divide them by a big number so that the pan doesn't move really fast. And then I move the Earth slightly based on that amount of pan for the delta X and delta Y. Now the gestures have other properties, so feel free to look at these files and look at all the properties. Anyway, they're all documented there. Have a go. That's probably beyond the scope of this simple tutorial video, but there's ways to configure thresholds for movement and velocities and all sorts of goodies. So if you don't like the default behavior, look at those public properties of each gesture class and tweak to your heart's content. Let's demonstrate the panning of that Earth real fast. In order to pan, I have to do 2 fingers. So I got to do the shift key, and now as I move the mouse, it's as if I'm moving those fingers around, panning the Earth. Pretty simple. Alright, thanks for bearing with me if you're still here. Congratulations to you. I really hope this is valuable to you. Scale gesture is a pinch and zoom gesture, very simple. Create your gesture, set the updated method to the callback and add it. Callback's very simple and says, hey, if I'm executing, let's do some scaling. Set the local scale and multiply it by the scale multiplier. That's basically how this works. Whatever object you're zooming in or out, simply multiply its current zoom value with the scale multiplier of the gesture, and that will help it smoothly zoom in and out. I'll show that to you real fast here with the, I think it was the control key. So I'm zooming out by pinching in and zooming in by pinching out. That's a very common gesture on mobile devices. Okay, we are now almost done. We have 2 more gestures left and then we'll be done. The rotate gesture also extremely easy to set up. Same as the scale gesture. And here's the callback. Before executing, rotate this Earth by the rotation radians delta and convert it to degrees because Unity works in degrees just about everywhere. So make sure to convert all these radians values to degrees when you're using this in Unity. Let's go ahead and rotate the Earth so you can see that in action. I think that was the Shift key to rotate this. As I do the mouse wheel, it pretends that the fingers are going around in a circle in a common rotate gesture. Okay, last gesture, the long press and hold to flick asteroids. Long press and hold, very simple. Here's the callback, long press gesture callback. Okay, so when the long tap begins, I start a drag, which basically says, hey, if I'm under an asteroid, set it as the currently dragged asteroid, and using a raycast I can find that. If I long tap on something that's not an asteroid, I immediately reset the long press gesture, which basically aborts the gesture and puts it back in the default state. So assuming I got a dragging asteroid, we'll look at the executing state. So now I've got an asteroid. I'm going to later on get back here and it's going to say, hey, I'm executing a long press. So a long press and hold moved somewhere. So that means this asteroid needs to move. So I find out where in the world the long tap is currently at and I move the asteroid to that position. Finally, when the asteroid ends the drag, I do some velocity calculations in case they did a flick while they were moving the asteroid around, and I apply some force and velocity to the asteroid so that it flies across the screen. So that is done here on the ended state when the long press ends. And then that will be the last demonstration. So remember, single tap to add asteroids, double tap to remove them, swipe to shove them around, and let's tap and hold this big guy here. Now I've got him. Can move him around here. If I let go without flicking, he doesn't really do anything, but if I move him around and then flick him, if I do that, he'll fly off the screen. There we go. And the asteroids have colliders on them so that they fly all over the place, so that's kind of fun. That's pretty much it for this asset. It's a lot of work has gone into these gestures. I think they are on par with UI Gesture Recognizer on iOS. I really think they're top notch. If you have any questions, email me at jeff@digitalruby.com. I'm more than happy to help you out. And have a look at this code. Complete demo script. We've gone through just about everything here. I think the only thing I didn't go through is this, which is the swipey lines. And then this is what draws the touch circles. And that's literally the whole script here. So I hope these work well for you in your game. And thanks for watching. And good luck.